So over here we've got a push-pull amplifier, and it actually uses the following components and the measuring instruments or instruments. We are going to have an AC signal going in, and we're going to use a function generator, so it will give us 1 volt VRMS at a frequency of 100 Hz, and also we're going to have a capacitor here which is 0.03 microfarads, and we're going to have 2 resistors here which is 100k and 100k down there, and then we're going to have VCC 12 volts, so we're going to use the power supply for that. And then we're going to have 2 transistors. It's basically your NPN, so this one's going to be the NPN, and then this side we're going to have the PNP, and this side we're going to have a capacitor which is something like 22 microfarads, and then we're going to use this RL, it's actually the load, which is 100 kilo ohm. And basically how this circuit works, we are going to put our channel number 1 here on the input just to see the full wave that is being sent to the circuit itself, and then we're going to put channel number 2 here of the oscilloscope just to see the output of it. So theoretically it needs to work this way. If we have the input here, the full AC signal going in, so it's going to be something like this. That's the input, and then the way in which the output will react is in the following way. Now with the NPN, it only switches on when you give it a positive cycle. So I'm just going to name this one positive cycle, negative, no, positive and negative. So when you give it a positive cycle, then the NPN will switch on. And then with the PNP, when you give it a negative cycle, that's the only time it will switch on. And then in order for the NPN to switch on, and then also with the PNP, it will need something like 0.6 or 0.7 volts to switch on. So basically this voltage here, if you want to switch on your NPN, it needs to reach to 0.6, and then that's the time it will switch on. And then similarly to the PNP, it will need a negative 0.6, so meaning a voltage pushing in a different direction, and then that's the time it will switch on. So they are not going to switch on at the same time. It will be one switching on, and then after when that one is switched on, then the other one is going to switch on. So I'm just going to draw this wave like this. On the vertical side here we've got voltage, and then this side we just got phases. So we've got from 0 up until 180 degrees, and then up until 360, that is the full cycle, just like that. So what's going to happen is that we'll wait for the voltage to reach to 0.6, and that's the time when our NPN will switch on. And then I'm just going to draw a line going there, going down there, so that we can actually see the reaction. So meaning we are expecting an output at that particular time when the voltage is at 0.6, and then eventually when the voltage reaches to 0.6 or less actually, so what's going to happen is that the transistor will switch off. Remember, the transistor needs 0.6 or more to switch on, or 0.7 depending on the type of transistor that you are using. And then this side, that's when we're going to have our PNP. With our PNP, remember, we'll need a negative 0.6. So I'm just going to do it like this, and then we'll say at that time, that's when our transistor, which is the PNP, will switch on. And therefore we can say somewhere there, that's when the transistor is actually below 0.6 or 0.7, and then it will eventually switch off. So I'm going to draw a line also going down there, and therefore the same thing, we can say our 0.6 is somewhere there, that's for our NPN, somewhere there, and then you can draw a line joining it down there. And remember, this only happens if you give it a sine wave. It's a different story when you give it a square wave. So I'm gonna just put it here, you can say somewhere there, that's when it's actually below 0.6, meaning the pulse is now going down. And then we're gonna have something like this, and then this side we're gonna have our negative 0.6, that's going to be for our PNP. Therefore we take it down there, take it here, and therefore this side is gonna be like this, and therefore that's when it's actually below negative 0.6 or negative 0.7. Right, so we've got those times. So basically in between here, or for that duration, it means that our transistor is actually active, and in this position it's no longer on. And then the same thing, this time is when it's on, and then here it's no longer on. Right, so what's going to happen is this: when you give it a wave, in the positive half cycle, it will wait until the voltage rises to 0.6, and then when it rises to 0.6, remember now that we're giving it in a positive cycle, so meaning we are going to leave out the PNP. Why? Because it will only switch on when you give it a negative cycle, so we're only focusing on this one. So this transistor, it will switch on, and then what will happen when it switches on? It will source power from the VCC there, and therefore current will flow through the collector. This is the collector side, this is the base, and this is the emitter. It will flow through the collector side, and then it will go down through the emitter. Remember now that we need to give 0.6 or 0.7 and even more so that the transistor will switch on. So if we give it any voltage less than that, what happens is that there is a higher resistance created between the collector and the emitter. But if we give it 0.6 or 0.7 even more, then there's going to be a less resistance, hence charges they can flow through the collector down through the emitter like that. And then here we've got a resistor there, and then what will happen is that when it reaches here, it will want to divide. So but the problem is that it can't go through this one. Why? Because remember now that we didn't give it a negative cycle, so there will be a high resistance recreated between the emitter and the collector. Look at this one. Here's the emitter and the collector, and then here we've got the base. Why? Because we didn't give it a negative cycle. So eventually the charges, they will flow through this capacitor there, and therefore through the load. So what will happen is that the oscilloscope will record that at this time the transistor was not on. However, when the voltage was at 0.6, then it will record a pulse there in that particular direction, and then it will show you that here the transistor was actually off. So we'll have a cycle like this, and then what will happen again is that for that time, then the transistor is actually off. And then if we give it a negative cycle, that is negative 0.6 or negative 0.7 going up, what will happen is that this transistor now, it will be active because we're giving it a negative cycle. And then once it's on, what will happen is this: it won't be able to source power from the VCC because now the charges, they need to flow through the NPN, and at that time is actually off because we're giving it a negative cycle. So it will source power from, remember now in the first case, the power was going, or the charges were flowing in this direction, so it will source the current from the load, and then it will take it down to ground. So basically it will source it from the load, it will go in that direction, and then in the first case it was going in this direction. So we're going to have charges flowing in this direction and then charges flowing in that direction. So the oscilloscope will record by showing you the pulse in this direction. So basically when you talk about positive and negative cycle, we're just talking about the direction of the current, or the direction at which the EMF or the voltage is pushing at. So it will do it in this direction, and then eventually we'll have something like this, and then something like that. So we're going to have a cycle like this. So we'll have that time delay here, and then that time delay here, and then I'll show you how to overcome this time delay. We're going to put the diodes for that. So basically we're going to connect the circuit for it, and then I'll show you how it works. Right, I've got components here. This side, I told you I'm going to use a function generator, and then I've got my 33 nanofarads here. I've got the 100K, the other 100K here, and then this side I've got a 470, and then a 470 there. I've got a polarized capacitor here, which is a 22 microfarads, and then on the load you don't really need to use 100K. And this side I've got actually this one is going to be a 1K, and then I've got our NPN transistor here, and then I've got our PNP transistor. You need to check also the number for it. This one I've got 3904, that's actually our NPN transistor, and then this side I've got 2N3906, that's going to be our PNP transistor. And then I've got my breadboard over here, which I'm going to use to build on, and then I've got my multimeter here just to do some few measurements, maybe your resistance and even your capacitance, just to see if you've got the right components. And also I've got my connecting wires and the power supply, and I'm also going to use the oscilloscope so that we can verify this output wave here. Okay, so I'm going to connect my components. So this side I've got I need to put my NPN, and then this other side I'm also going to put my PNP. So now on my NPN, you will realize that if I put it this way, this side I'm gonna have the emitter, and then this side I'm gonna have my base, and then the other side I'm gonna have my collector. That is going to be for my PNP transistor. So I'm gonna have the emitter, the base, and the collector. So I'm just gonna put it like this, and therefore have it there, then have it there, and then over here I've got my PNP transistor. So on my PNP transistor here, I'm also going to put it on the side. So I can connect this one here. So that's my PNP. I've got my emitter, base, and collector, and then this is my NPN. I've got my base, emitter, and collector. So what I'm gonna do is this. Remember, now I need to connect the emitter of this one and also that one that side. So with this one I can just put the base like this, and then I've got the emitter there, and I've got the collector, so I can actually make it to face there. And then I'm gonna connect here, connect this one, and therefore I'm gonna connect the base this side. So I'm just going to connect it like this, and this is going to be my base, it's going to be my PNP, and then also this side is the NPN. I've got the emitter, base, and collector. Then I can just connect it like this. It's going to be the base, then I can just put it like that. So I can just put it like this. Let's just put it like that. Okay, so I have it like that. That's my base, that's the emitter, that's the collector, and then the base. Right, so I'm gonna take this one, this capacitor over here, I can just put it here, or rather maybe I can even put it this side, it's fine. So I can put it here, it says at the base there, so I can put it somewhere there, that's the base, and put it over there. Okay, and then I can put this wire over here, that is to show that it's going to be the input from the signal generator, giving me the AC there, so I can just put it there. And therefore I'm gonna need my 100K. This 100K here needs to come from the VCC and then to the base of this one, so I'm gonna just connect it here, and therefore connect the other leg on the other side. I can just connect it here. So this is gonna be coming from the VCC. I can just take a small wire there, can even take this one. Okay, I can take this one and then just put it here. And therefore I know that this one is going to be the VCC, and therefore I just need a wire to connect the base of this one and the base of the other one. So I can just take a little bit longer wire, I can take this one and then connect it here on the base, just here, the base, and then connect it with the base of this one. So it's going to be something like that. And therefore I also need another 100K here from the base down to ground, so I can just connect it here and then put it this side, and therefore I can just connect this wire here to show that's going to be the ground. So there are quite a lot of things that I'm going to connect on this ground, so I can use this wire, so I can actually connect a lot of them here. So it's always good to divide your lines. Just have VCC this side and then you can have ground this side. Though you've got two of them, but it's always confusing when you're just using this one as the VCC and the other one as ground. But it depends on how complex your circuit becomes. If it's more complex, then you're going to have to use these two and also this two. But with this one, because it's a little bit simple and less complex, then you can just divide it nicely. So that can also make sense to you if you're going to be doing troubleshooting. And then now the other thing that I'm going to need, I'm just going to need a wire from the VCC to our NPN here. So I can just take this wire and then it goes to the collector, which is actually the collector of the NPN. So I can just connect this collector over here and then source it. If it's not that long, so I can actually take this one, connect it here on the collector, and then take it from the VCC. So you'll notice I'm always using the VCC this side. So I can actually take this one, take out this wire, and then just put it here. Just wanted to put them close, so it's fine. So it's gonna be, so this one needs to go to this line. So that's our VCC there, right? So from the emitter of this one, I need to connect that 470. So I can just take the 470 there and then connect it here, connect it there, and then put it here. I can just connect it and put it here. Okay, so another thing that I'm gonna need, I'll need says I need to put a capacitor here, so I need the positive side. The best way to see this, on the negative side we've got this this negative here, or this dash here shows that this is a negative, and therefore I've got positive there, and therefore I can just put one leg this side. It says that it needs to connect to the load, so I can connect this one here and connect this one there, and the load needs to go to ground, so I can just connect it like this, positive there, and therefore on the other side of the leg I can put this resistor here. So actually 1K, I can just put it here, and therefore take it down to ground this side. And therefore what I'm gonna do, I'll just take it says I need to have the other 470 just in parallel there, so it needs to go to the emitter of our PNP, so I can just connect it here, take this one here, and therefore connect it this side like that to the emitter of this one. And therefore now the collector of this one, I just need to take a wire, take it down to ground, so I can have this wire here. So I can just shift this one and then put it on this line. Okay, so it's still fine, and then I can just take this one here, just put it here, it's also fine. And therefore now I can just take the collector of this one, collector, and then also take it down to ground. So where am I going to be measuring my output? I'll just measure it here, actually measure it here, so I can put a wire this side, channel number 2 here, so I can put the wire here. That's going to be where I'll be checking my output. Just see if I can put it in here. Okay, so it's going to be the output there with the brown, and therefore this side I've got my VCC, and on the side I've got my input from the signal generator, and then here I've got my ground. So that's how I'm going to be doing it. Alright, so over here we've got our power supply, which is actually taken on 12 volts, and then this side we've got our function generator, which are generating a wave that is having 1.0 VRMS. And then remember, in order for us to get the amplitude, it will be 1.0 multiplied by square root of 2, it will give us a 1.414 there. And then now we've got our oscilloscope this side. So on the yellow one, which is actually the input, and then we've got the blue one, which is actually the output. And then if you can see there, the yellow one is taken on 2 volts per division. Maybe I can just take it to 500 millivolts so that we can have the same scale. Okay, if I can leave it there to 1 volt and then try to take the output also to 1 volt, because it's been taken to 500 millivolts. Can just take it to 1 volt. All right, so that's fine. So now we've got 1 volt on the channel number 1 and 1 volt on channel number 2. So you'll notice something, the yellow one is the input and the blue one is the output. If you can look at this is actually where we're getting that time delay. It's waiting for it to switch on. So the output is going to be like that, it will be having the time delay. So basically what we're going to do is this. If you can remember now, if you can look at the on the book itself, we spoke about the circuit being like this, and then here that's where we're going to put our diode. So we'll have our diodes here, the diode which will be facing down, and then two diodes facing down there, and then if you connect these diodes facing down like that, two of them, then we're going to be able to take out this time delay. And then I'm just going to connect it, and then from there we'll see how it's going to take out the time delay. Right, so now I'm just going to connect those two diodes here. I'll have one here, connect it here to there. Just try to connect it nicely. I'll just have it here. So let's see if it will just go nicely. Okay. So I'm going to connect the two diodes here. So I'll have the first one connected there. It's facing down. I connect it like this. And if I'm going to have the other diodes here, then also it will be facing down, and I'll just connect it here. And I'll just put the diode here, and if I can just put it on the other side here. Okay, so I'll take this one also in deep. Okay, so I've got two diodes here, and then for now I just need a wire, and then pull it to the base of the other one. I'll just connect it here and then take it to the base. It's actually this side. And then after putting the two diodes there that are facing down there, we end up having that sine wave, the smooth sine wave. We're no longer having the time delay there. So that's actually how to overcome that time delay that was actually caused by the transistor waiting to switch on as a result of the rising pulse from the input. So yeah, that's actually how you get your push-pull. So it actually amplifies current, and yeah, that's how it works.